So, Ulla, please, floor is yours.
Thank you for the introduction. Today I'll be talking about DER hosting capacity for distribution networks, typically about the definitions, attributes, use cases, and some challenges. So traditionally, DER hosting capacity has been defined in terms of distribution generation that can be accommodated without creating a negative impact on the quality or reliability, assuming under existing control and infrastructure configurations. Now, this definition does not consider all the stakeholders who might be affected in the hosting capacity assessment exercise. There are several rule of thumb based estimates, such as hosting capacity set based on the peak load or the minimum load demand, which was used in California and other parts of the world. It can be based on the transformer rating. There are rules in Germany which is based on the inverter sizing, so 70% rule. However, these estimates or the rule of thumb estimates does not scale very well when we talk about load hosting capacity, such as electric vehicles or heat pumps. So with this motivation, I'll be talking about a few questions. We'll try to go through 5 questions about definitions, classification of hosting capacity, what attributes should we be considering, what are the goals and the use cases of this exercise, and how frequently system operators or some other stakeholder should perform this, and what are the key challenges. And a bonus question that we'll go through is how can we classify the maximization of hosting capacity. And with these questions answered, possibly will help us in standardizing the hosting capacity assessment practices and applications. So DERs compose of distributed loads, distributed generation, and storage devices. Now, when we perform hosting capacity associated with either of these entities, the power quality metrics associated the deteriorating entities are not the same, which means that we have to often perform a separate exercise for load-based hosting capacity or EV hosting capacity or distributed generation hosting capacity. And especially if we look at the European context, what we see is the electric vehicle and heat pumps are growing at a very high pace. And these loads are problematic by nature because they have simultaneous behavior with high peaks. So this motivates us to define DER hosting capacity and not just BG hosting capacity. So oftentimes there is a discussion, is hosting capacity a planning problem or a operational problem? So there are traditional planning problems in which there is connection request processing, which the system operators do, or infrastructure planning or flexibility planning. And there are operational problems such as congestion management. And we believe that hosting capacity sits ideally in between the planning application and the operational application, which means that it can improve the planning, at the same time improve the operational aspects of distribution network. Before we jump into answering this question, we need to rethink like what are the stakeholders associated with the hosting capacity assessment problem, and we can list all these entities here. And depending on which of these entities are we considering, will define, we have to rethink what exactly is the social welfare to be for that application. So we define not just one definition, but actually 6 variants of hosting capacity assessment, which are listed in the table on the right. So technical and dynamic hosting capacity are grid-driven or network-driven. Physical, economic, and regulatory are dependent on rules or availability of resources. And consumer-centric provides a unique way of thinking of the hosting capacity problem from the consumer angle. So if we look in detail in these classification, which I will not go in detail, we can see that the stakeholders associated with these problems are going to think of this problem in their own perspective rather than the global perspective. Especially a unique way of thinking is the physical hosting capacity, for example, in which the hosting capacity is not driven by the grid limitation, but the limitation on, say, the rooftop area of a region. So especially in urban areas where a lot of people are living in a smaller space, the rooftop space is going to be much more constraining than the grid assets And similarly, economic hosting capacity would define based on the cost-benefit analysis and the market products that the consumer can participate in order to justify installing a DER or not. Similarly, regulatory policies can be either in favor of the consumer or the DER owners to install, to make that decision of installing or not. And consumer-centric hosting capacity provides consumer engagement. It can be driven based on subsidies in a region and so on. Yeah. So combining all these, we come up with a new definition of hosting capacity assessment, which is the ability of the network to accommodate a specific or combined installed capacity of one or multiple DER, considering technical, operational, economic, physical, regulatory, and policies in an equitable manner in specific circuit without affecting the reliability of operation. So for example, I'll give a stylized example in which on the x-axis there is a time evolution, and on the y-axis is the renewable energy adoption. So let's say the physical constraints such as the rooftop area is limited by this line. The grid constraint, because the grid is evolving and there are upgrades happening, the grid constraint is going to evolve. The market constraint will be dependent on the tariff change and change in subsidies. And the evolution will look something like this, in which we have to combine all these aspects together to assess how the DERs are going to evolve. With this, we go to the second question, which is what exactly are the attributes of hosting capacity? So the first aspect is the temporal granularity. Are we talking about a multi-period problem or a snapshot or a worst-case problem? How are we modeling uncertainty, which is a critical component which makes it computationally non-scalable? What DERs are we considering? So ideally, system operators or what stakeholders should consider one or multiple DERs at the same time, because in another study we observed that the uncertainty of the combined is actually reducing compared to what taken one at a time. So this is a critical component. In what detail are we modeling the network? What is the spatial granularity are we considering? Is it feeder level or the substation level and so on? The analysis types can vary based on balanced or unbalanced case, based on steady state and dynamic application, and the scenarios considered, and finally the regulatory policies that needs to be considered while we assume the DER increasing in the network. The third question deals with the goals and use cases of hosting capacity. So as mentioned, there are several stakeholders, and each of these stakeholders will have their own way of looking at the problem. A policymaker or a market operator would consider facilitating policies which are favorable for all the stakeholders. A system operator would consider optimal operation and planning for the grid while minimizing the connection request. Social welfare-wise, it will support decarbonization, empower consumer engagement, and it will effectively lead to cost-effective DER integration. And from the consumer perspective, it will provide a fair opportunity for consumers to connect or install DERs irrespective of where they are located in the network. So this can essentially lead to faster DER connection requests. So when we go to the use case of this, so hosting capacity maps are being used widely by system operators all over the world. So it provides a network inadequacy which causes delays, connection delays for new or updating existing supply and demand requests. So hosting capacity maps provide a visual representation of availability of the network to connect additional DER. And this is a transparent way of providing this information of grid availability. So as an example, which a lot of people use in Netherlands, where the distribution network and transmission network availability is shown, the white regions, which are the regions where new connection requests can be processed without having any delays, while for the red ones, the network operator has to upgrade the local network or provide an additional consideration before processing the request. So this leads to a huge amount of delays. The fourth question is how frequently the system operator should perform this exercise. So right now the status quo is there is no set guidelines for most of the system operator, But some of the system operators, especially in the US, they perform it either at a regular interval, possibly quarterly or yearly. It can be driven based on changes in the network, such as network reconfiguration or upgrading the network. It can be based on a regulatory requirement that every time we process infrastructure upgrade, we will have to consider what is the amount of spare capacity left. And the ideal scenario would be to consider it close to real time, which we are far off. So there are many challenges associated with hosting capacity. The biggest one is there is lack of standardization. So the notion of hosting capacity varies from one entity to other because of no unique definition, and there is ambiguity in terms of what are the underlying assumptions that the system operator or any entity is considering. And the other problem is computation, of course, for which we are trying to make it more and more scalable. Just for example, in UK there are a million plus feeders. So if we have to consider this exercise, which needs to be performed for a very long time, it takes a huge amount of computation. And finally, that I would like to point is hosting capacity, often generated by system operator, comes with a disclaimer that this the system operator is not obliged to meet those risks if someone makes a decision with using those maps. So I think this discourages and brings down the trust of someone using these maps. And the last question that I'll be discussing is how can we maximize hosting capacity? And there are many strategies such as non-intrusive solution in which we use certain smart algorithms such as smart meters. It could be based on policy or market driven. It can be based on active devices which will then essentially lead to additional investment. It can be based on network upgrades, and finally it can be curtailment or load sharing. So the last one is the least desirable solution for us, and this gives us a whole perspective on maximizing hosting capacity. With this, I will conclude my presentation. There is a need for standardization of hosting capacity across DERs and stakeholders. There is a fair and transparent way of exchanging information using hosting capacity maps, which all these stakeholders should use. By analyzing these hosting capacity objectives, modeling details, use cases, and frequency of updates, it will enhance its usability for all the stakeholders in distribution. Thank you for your attention.
Do you have any questions from the audience? Yes, there is one. Please.
I'll wait.
Very interesting, Uma. With the relation to your IT side of the subject, have you contemplated or have you used the common information model for the structure interchange between the SIM?
Yeah, but then SIM also is not very universal because it varies from, I think there are also many versions of SIM. If I understand correctly the question, you were saying that SIM is already a standardization model of data exchange between for the network layout, right?
Yeah, look, I'm involved with it a bit, so that's part of the reason why I asked the question. And it's an evolving space. So I know that there's standardisation in there that can be used, but I was curious to see what you were doing, if there was any use cases you've utilised, what's there to help simplify that process.
Yeah, thank you for the question. Of course, there are several fronts of this this problem. SIM and the pushing of system operators to unify how the network layout information and uncertainties are modeled is one step towards that. But when you mix a lot of it, like DERs and the growth of DERs, and many times system operators does not have the activation of DERs connected in the network, which is a very negative thing because and there is an incentive for sometimes consumers to hide the DER, such as electric vehicle. I mean, PVs are normally subsidized, but adding a connection charger at the home, there is an incentive for the consumer to not disclose it completely. So I think there has to be some measures in that direction where we can understand what is the status quo and what will happen if we have more DERs in the system. Especially if you look at, I gave it in one of my slides, the example much it's
Thanks. Very interesting presentation. I was wondering, so you listed all those different variants of hosting capacities together with the different use cases, and I hope I didn't miss it, but my question is, did you do a mapping of use cases to those variants? So which variants are most suitable for which use cases in that space?
Okay. You mean the 6 definition and which of these are mapped where? Do I understand it correctly? So most of the time right now, what is being performed is the first 2, which is let me go back. Sorry. Yeah, so the technical hosting capacity is the traditional hosting capacity. So I think this is what is presented. So there is like a one-way communication between the system operator and the consumers, and not the other way around. But what we are saying is, since there are so many stakeholders, each one should have their say into the process because they are getting affected, especially in distribution networks which are inherently unfair because of the radiality which is driven by the economics of it. So it does not provide a fair opportunity to all consumers connected in the feeder. So I think equitable access of DER is an illusion in a radial network. Sorry, I don't understand, did not explain the question properly because I think it requires a bigger discussion. The use cases are mostly technical hosting capacity. So we went through many such exercises in US and in Europe, and most of them were technical assessment by the system operator.
Thank you for the presentation. You mentioned standardized hosting capacities. I really like the concept, but given that all countries and all DSOs are implemented, usually there's a technical aspect, but there's always some kind of regulatory aspect on top. It's not just pure technical, the assessment. So is this even standardizable in practice?
I think there is definitely a difference between one system operator and the other in terms of what communication exchanges can happen, how uncertainties can be modeled, what access to data they do have, and they have to adapt those definitions based on the thing that they have at their own networks, and they have to adapt these models, but not explicitly mentioning the assumption of the study makes the study not non-challengeable. Right? So if we, I agree that all networks are not at the same position, neither the system operators, but the assumptions are not explicitly detailed for someone to understand what are the flaws of the method itself.
Yes, please another question.
I have a very short question to you. It's a very nice overview that you have presented. I was wondering that what frequency do you suggest for the DSOs to update this kind of hosting capacity of their network?
I think I like Vermont. I think there's a DSO in Vermont, and they suggested that whenever there is a major change in the network or whenever you update the meta information of consumers, you should reassess it. So basically, we cannot do it like at a very high frequency. But suppose there is a new decision to be made. Of course, when we are doing infrastructure upgrade decision, I think it's essentially a hosting capacity assessment because you are trying to find the weak link in the network which needs to be updated. But whenever there is a major change in the network, this study should be prescribed.
Thank you. And about the power quality, are you going to also consider harmonics in your assessment?
I think harmonics is a far-fetched goal because firstly the smart meters are measuring steady state measurements. So we can do harmonics at the substation level possibly because you might have more measurements at the substation in the secondary substation. But at the consumer end, we don't have access to anything beyond RMS values. So I think it will be harder to. There might be a policy for the inverters, like an interconnection guideline that what harmonics can they inject, which is already there, I think, for larger inverters, not the residential scale inverters. But I think harmonics is something we'll eventually reach, but there are some steps to be covered in between.
Well, it's time for an advertisement. I invite all of you that on Thursday at 11 at roundtable number 15, which should be exactly about how standardization can contribute to planning and development of distribution network. We will have some colleagues from IC that could eventually elaborate a little bit about what presently being done in IC about hosting capacity, but not just hosting capacity. So